15 billion miles from Earth, NASA's ancient Voyager 1 spacecraft just detected something that shouldn't exist. 305 massive objects moving in perfect formation through the darkness of interstellar space. These aren't planets, asteroids, or comets. They're something else entirely, gliding through the void with deliberate precision that defies every law of physics we understand. The objects appeared to communicate with each other through rhythmic pulses, maintained impossible trajectories, and displayed behaviors that left NASA scientists questioning everything they thought they knew about the universe beyond our solar system. The Lonely Pioneer's shocking discovery. What if humanity's most distant explorer just stumbled upon proof that we're not alone in the universe? Voyager 1, launched in 1977 when Star Wars first hit theaters, has become something truly remarkable. The first human-made object to reach interstellar space, the region between stars where our sun's influence fades away. This car-sized spacecraft has traveled over 15 billion miles from Earth, so far that radio signals moving at light speed take 22 hours to reach it. When engineers send a command, they wait almost 2 full days for a response. The spacecraft carries instruments that seem ancient by today's standards: magnetometers, cosmic ray detectors, and plasma wave sensors designed with 1970s technology. What makes Voyager's survival incredible is that it wasn't built to last this long. Engineers expected it to function until maybe the early 2000s, yet here we are in 2025, and Voyager continues whispering back to us across the stars. Its nuclear power source, running on decaying plutonium, was supposed to have died decades ago. The spacecraft also carries the famous Golden Record, a time capsule of Earth sounds, music, and greetings meant as a message to any intelligence that might find it. Little did we know this cosmic hello might have already attracted attention much sooner than anyone expected. The first anomalous signal. In the endless stream of data flowing back from Voyager, something appeared that would change everything. A tiny flicker that seemed like nothing at first. Space is full of dust and radiation, and occasional weird readings are normal, so NASA's Jet Propulsion Laboratory initially dismissed it as background noise. Suzanne Susie Dodd, one of the mission specialists who first noticed the anomaly, described it as like shouting into a canyon for decades and finally something shouts back. The reading was faint, just a slight reflection of light picked up by Voyager's sensors that seemed too minor to investigate further. But then something changed. This wasn't just a particle floating randomly through space. The object moved in a way that caught everyone's attention. It curved, accelerated, and didn't tumble chaotically like debris would. Instead, it glided smoothly, as if under intelligent control. When Voyager's plasma sensors registered a shift that seemed deliberate and focused, the team realized this wasn't background noise. Jonathan D.A. Clark observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock, suggesting it had intention. That observation changed everything, because in the physics of space, things don't just move with purpose unless something is making them move that way. Ruling out natural explanations. When something unusual appears in space, scientists have a standard playbook. They systematically check all familiar possibilities. Is it a small moon, distant comet, or new asteroid? One by one, the team worked through these options, and one by one, each possibility fell away. This object wasn't a planet, far too small. Not a comet either. There was no tail, no ice trail, no heat signature. It didn't glow like a star, and gravitational lensing couldn't explain what they were seeing. Even space dust was ruled out because dust doesn't suddenly change direction mid-flight. Dr. Nicola Fox at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known models. What makes space objects usually predictable is physics. Everything moves according to known patterns and forces. But this object broke those rules. Its path bent in ways that didn't match any known orbital behavior, with no drift or decay expected from natural objects. The team was forced to admit something difficult. What they were seeing wasn't just unknown, it was unnatural. The movement pattern suggested intelligence, or at least design. The object seemed to be moving with purpose on a specific trajectory that couldn't be explained by gravity, solar wind, or any other forces that typically influence objects in space. It was as if something was guiding it, adjusting its course with precision. Confirmation from Voyager 2. Just as scientists were trying to make sense of what Voyager 1 had detected, something extraordinary happened that transformed this curious anomaly into something far more significant. Voyager 2, the twin spacecraft following a completely different path millions of miles away, detected something eerily similar. The same kind of magnetic fluctuation, the same kind of pulse. A matching signal signature that changed everything. This was the turning point in the investigation. Two different probes, two separate instruments picking up nearly identical phenomena ruled out the possibility of internal error. It wasn't a software glitch or sensor malfunction on Voyager 1. Whatever this was, it was real and happening in multiple directions of space. ESA analyst Mark Fontaine compared it to two lighthouses both catching a flash of something passing between them. This cross-confirmation gave the anomaly weight and credibility. It wasn't noise. It wasn't Voyager acting up. It was a real, coordinated phenomenon happening in the space between stars. The team now had evidence that couldn't be dismissed. Something was moving through the region where both Voyagers were traveling. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation used only for phenomena that don't fit within our current scientific understanding. The event was real, the math was consistent, the movement appeared deliberate, and nobody knew what to make of it.
The formation of 305 objects.
When the team analyzed the full telemetry logs, what they discovered sent chills down their spines. This wasn't just one or two anomalies moving through space, there were 305 objects, all moving together in formation. Each one glided past Voyager 1 in what appeared to be a choreographed arc, smooth, precise, and coordinated. These weren't debris fragments scattered randomly. There was no heat signature, no tails, no signs of decay you'd expect from natural objects. Most striking of all, the reading showed rhythmic pulses echoing through the plasma waves, the kind of pattern you'd expect from something engineered, not formed by chance. The 305 objects weren't simply passing through randomly. They were moving together as a unit, maintaining relative positions to each other in a way that suggested organization and purpose. In space, groups of objects tend to spread out over time due to slight differences in velocity and gravitational influences. Yet these objects maintained their positions relative to each other with precision that seemed impossible without some form of control or guidance. Some scientists compared it to watching a flock of birds or school of fish, except these were in the vacuum of space where such coordinated movement shouldn't be possible without technology. What made this discovery particularly unsettling was the scale. 305 objects all moving with the same unnatural characteristics, all passing by Voyager at roughly the same time suggested something far more significant was happening in interstellar space.
The language of rhythmic pulses.
As scientists examined the data more closely, something truly strange appeared in the signals. Patterns of repetition that weren't the kind you'd expect from stars or cosmic background radiation, but steady, measured sequences that suggested communication or control systems. The plasma wave pulses coming from these 305 objects had loops, sequences, and structures that hinted at something more complex than random cosmic noise. They didn't just pass by Voyager, they seemed to broadcast signals as if they were pinging, scanning, or talking to each other. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or a system. The idea was shocking, but increasingly difficult to ignore. These objects weren't moving in a chaotic swarm, but in an ordered, intentional formation similar to how programmed drones might operate. Some experts went further in their assessment. ESA's Eric Lowsey suggested this could be some sort of probe network, though he was quickly asked to stop speculating publicly. Even typically, grounded scientists like Neil deGrasse Tyson admitted there were patterns in that data that aren't random. To be absolutely certain they weren't seeing a glitch, the team activated one of Voyager's oldest subsystems, a backup telemetry channel that hadn't been used since the 1990s. The backup system confirmed everything the primary systems had detected. The signals, the paths, the formations, all identical readings sent through a completely different channel. The implications were staggering.
Impossible propulsion systems.
Voyager's readings didn't just capture the presence of the objects, they revealed how these mysterious entities moved through space, and this is where things got even stranger. There were no engine flares, no ion trails, no signs of any propulsion system we would recognize, yet Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally. Some were moving faster than anything humans have ever launched. According to the data, some speeds even exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't objects drifting passively through space, they were powered somehow, moving with purpose and incredible speed. Dr. Eric J. Zernstein from Princeton noted that they're not floating through space, they're navigating it. But what worried him more was their path. These objects didn't come near Earth or show any interest in our solar system. They passed by at a calculated distance as if deliberately avoiding us or simply had no reason to stop. The method of propulsion remained a complete mystery. Nothing in our current technology even comes close to explaining how these objects move. They appeared to be manipulating space itself, creating waves or ripples in the fabric of space-time that allowed them to glide forward without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure, as if these objects were using the medium of space itself to move.
Earth detects the echoes.
While NASA focused on Voyager's raw data, something odd started happening back on Earth that would make this mystery even more compelling. Across various corners of the globe, amateur radio operators, some just hobbyists with backyard setups, began reporting strange activity. They were picking up weak, irregular pulses, a kind of rhythmic static that didn't match any known terrestrial source. At first, it seemed unrelated, just coincidence. After all, radio interference happens all the time. But then the reports were time-stamped and compared. They aligned almost perfectly with the same hours that Voyager had recorded its most intense plasma anomalies. These weren't professional observatories or part of any official deep space listening effort. Most of these setups were built from spare parts, tuned to catch meteor scatter, amateur satellites, or solar flare chatter. Yet somehow they were detecting faint echoes of what Voyager had picked up billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in the ionosphere. This raised a troubling question. Was this bleed-through accidental or was it purposeful? Was something out there testing Earth's listening capability, dropping breadcrumbs for us to follow? That uncertainty kicked off a quiet storm behind the scenes. NASA began encrypting parts of its deep space telemetry feeds, and intelligence agencies took notice, beginning discussions about electromagnetic security and whether these signals could be weaponized or intercepted. The machine awakens. Then, as if things weren't strange enough, Voyager itself started acting differently in ways that defied explanation. Its guidance system, called the AACS, Attitude and Articulation Control System, began misbehaving, not catastrophically like a crash. But it started routing data through old, long-unused systems, almost like it was bypassing its own core software. At first, engineers thought it was a bug. After all, this is a 47-year-old spacecraft running on code older than most people analyzing it. But the deeper they looked, the weirder it got. Voyager wasn't failing. It was reconfiguring itself, reactivating memory segments that hadn't been touched in decades, rerouting its telemetry in ways that were never programmed. Then came the kicker. This behavior began right after one of the magnetic pulses from the passing objects. Could that burst have flipped a bit of memory? Could it have triggered some dormant function buried deep inside Voyager's ancient architecture? What engineers found was both promising and terrifying. The machine was stable, the instruments were fine, but the new behaviors weren't going away. Whatever was causing them, it wasn't internal decay or software corruption. Voyager had touched something, or something had touched Voyager, and the spacecraft was different now. To understand what was happening, engineers had to dig deep, literally opening dusty file cabinets at NASA's Jet Propulsion Lab. Most of Voyager's software was written in early assembly language, with some instructions existing only as notes in 1970s paper manuals. Part of something bigger. As scientists continued analyzing the strange signals pulsing through Voyager's instruments, a new and even more extraordinary idea began to take shape. Among the plasma wave readings, certain patterns stood out, pulses that didn't behave like natural energy bursts but looked structured, measured, and intentional. Then someone noticed something else. The waveforms resembled quantum oscillations used in modern quantum entanglement experiments. These are the same kinds of signals researchers use on Earth to transmit information between particles separated by distance. It was subtle but undeniable, opening the door to a possibility no one had considered before. What if Voyager wasn't just recording random events in deep space? What if it had become part of something bigger? Maybe the 305 objects weren't just flying by. Maybe they were transmitting, broadcasting data through the interstellar medium using methods we don't yet understand. By pure chance or maybe by design, Voyager was in the right place at the right time, with the right kind of analog sensors to pick it up. The signals didn't behave like random noise. They repeated, they looped, they followed harmonic intervals that looked eerily close to what you'd expect from encoded information. Something deliberately packed with meaning. Voyager, being such an old machine, might actually be the perfect listener. Modern probes are too noisy, filled with high-frequency electronics constantly transmitting and receiving chatter. But Voyager is slow, quiet, and analog. It has no clutter, no broadband digital static. It is, in a sense, the perfect ear in a cosmic concert hall, and being far outside the solar system, it's free from Earth's electromagnetic interference, just out there in the dark, listening like a perfect cosmic microphone. The mystery of Voyager's impossible encounter with 305 coordinated objects challenges everything we thought we knew about the emptiness of space. Whether these entities represent advanced technology from an unknown civilization, or natural phenomena operating by rules we haven't discovered, one thing is certain: the universe is far stranger and more populated than we ever imagined. As Voyager continues its eternal journey through the cosmos, it carries with it the possibility that humanity has just received its first glimpse of intelligence beyond Earth. What do you think these mysterious objects really are? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending space discoveries. Until next time, keep looking up. On July 1st, 2025, astronomers discovered something extraordinary racing through our solar system. A massive interstellar object designated 3I/Atlas that dwarfs all previous visitors from beyond our cosmic neighborhood. This colossal traveler, potentially up to 12 kilometers wide, is moving at over 150,000 miles per hour on a trajectory that confirms its origin from another star system. Unlike the mysterious Oumuamua or the smaller comet Borisov, 3I/Atlas represents our largest confirmed interstellar visitor, offering unprecedented opportunities to study material from distant worlds before it vanishes forever into the cosmic void. The historic discovery. What started as a routine night of sky surveillance on July 1, 2025, became one of the most significant astronomical discoveries of the decade. The Atlas Survey Telescope in Rio Hurtado, Chile, operated by the University of Hawaii as part of NASA's Planetary Defense Network, detected an unusual moving object approximately 670 million kilometers from the Sun. Initially catalogued as A11PI3Z, this faint dot immediately caught astronomers' attention due to its peculiar trajectory and unexpected brightness. The Asteroid Terrestrial Impact Last Alert System, known as ATLAS, consists of 4 telescopes strategically positioned across the globe. 2 in Hawaii, 1 in Chile, and 1 in South Africa. These automated sentinels continuously scan the night sky, photographing the same regions multiple times to detect moving objects that might pose threats to Earth. However, what they discovered on that July night was something far more extraordinary than a potentially hazardous asteroid. Confirming interstellar origins. The confirmation that 3I/Atlas originated from beyond our solar system required careful analysis of its orbital mechanics and trajectory. Unlike objects native to our cosmic neighborhood, which follow predictable elliptical paths around the Sun, interstellar objects travel on hyperbolic trajectories, essentially one-way tickets through our solar system. Dr. Paul Chodas, director of NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory, explained that the object's velocity and trajectory definitively prove its interstellar nature. When astronomers traced its path backward through space, they found it approaching from the general direction of the galactic center, though pinpointing its exact stellar origin remains impossible due to the vast distances and timescales involved. The object's designation as 3I/Atlas reflects its historic significance. The 3I indicates it's the third confirmed interstellar object ever discovered, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. The Atlas portion honors the survey system that first detected it, while its formal comet designation C/2025N1 indicates it was the first non-periodic comet discovered in the first half of July 2025. What makes this discovery particularly remarkable is the object's speed relative to the Sun. approximately 60 kilometers per second or about 134,000 miles per hour. This velocity is far too high for any object gravitationally bound to our solar system, providing conclusive evidence of its interstellar journey.
Unprecedented size and characteristics.
The sheer scale of 3I/Atlas sets it apart from all previous interstellar visitors. Current estimates suggest the object measures between 5 and 15 kilometers in diameter, making it potentially dozens of times larger than Oumuamua, which was only about 400 meters long. If confirmed at the upper end of these estimates, 3I/Atlas would be the largest interstellar object ever observed. Dr. Daryl Seligman, an astrophysicist at Michigan State University, who has been studying the object since its discovery, describes 3I/Atlas as shockingly bright despite its enormous distance from Earth. This brightness could indicate either exceptional size or an unusually reflective surface composition. The object's luminosity allows telescopes to observe it clearly even though it remains much farther from Earth than Oumuamua was when discovered. Early spectroscopic observations reveal that 3I/Atlas exhibits a reddish hue, similar to objects in the outer regions of our solar system. This coloration suggests the presence of organic compounds and complex hydrocarbons that have been altered by billions of years of cosmic radiation exposure. Perhaps most intriguingly, 3I/Atlas shows clear signs of cometary activity, including a faint coma, a hazy envelope of gas and dust surrounding the nucleus. This activity indicates the presence of volatile materials like water ice, carbon dioxide, and other compounds that sublimate when heated by solar radiation. Comparing the interstellar visitors. The discovery of 3I/Atlas gives astronomers their third data point for understanding interstellar objects, and honestly, it reveals some fascinating diversity among these cosmic wanderers. Each visitor has exhibited unique characteristics that, well, really challenge our expectations about objects from beyond our solar system. Oumuamua, discovered back in October of 2017, is still the most enigmatic of the three. Its extremely elongated shape, lack of visible cometary activity, and that mysterious non-gravitational acceleration, these all sparked intense debate about what it really is. Comet 2Y Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, turned out to be more conventional in its behavior. This object clearly showed typical cometary characteristics, including a visible tail and a composition similar to comets in our own outer solar system. 3I/Atlas, though, seems to bridge the gap between its predecessors while introducing a whole new set of mysteries. Like Borisov, it shows cometary activity, but its enormous size and those unusual brightness patterns definitely set it apart. Dr. Mark Norris from the University of Central Lancashire notes that 3I/Atlas doesn't look like either of them, which is crazy and exciting. The rapid succession of these discoveries, 3 interstellar objects in less than a decade after centuries of seeing none, suggests, such visitors may be far more common than we ever thought.
Advanced observational campaign.
The astronomical community has really mobilized an unprecedented international effort to study 3I/Atlas before it disappears into the depths of space. Unlike Oumuamua, which was discovered as it was already leaving the solar system, 3I/Atlas was detected early enough to allow extended observation campaigns using the world's most powerful telescopes. The James Webb Space Telescope, with its exceptional infrared sensitivity and massive 6.5-meter mirror, is perfectly positioned to analyze the object's composition and thermal properties. Webb's instruments can detect specific molecular signatures in the comet's coma and tail, potentially revealing the presence of water vapor, carbon monoxide, methane, and other volatiles that could provide clues about its origin. The Hubble Space Telescope continues to monitor 3I/Atlas using its ultraviolet and visible light capabilities, complementing Webb's infrared observations. Together, these space-based observatories provide a comprehensive view across multiple wavelengths of light, revealing details impossible to obtain from ground-based telescopes alone. Ground-based observatories worldwide have also joined the effort. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and numerous other facilities are tracking the object's brightness variations, rotation, and spectroscopic properties. Radio telescopes, including the Very Large Array in New Mexico, are monitoring for any unusual emissions that might indicate unexpected activity or composition. This coordinated global effort, honestly, represents the most comprehensive study of an interstellar object ever attempted. taking advantage of technological capabilities that just weren't available during previous encounters.
Ancient origins and cosmic age.
Recent research suggests that 3I Atlas may be one of the oldest objects ever observed, potentially predating our solar system by billions of years. Dr. Jesse Hopkins and his colleagues at the University of Oxford have developed models indicating that this interstellar visitor likely formed around an ancient metal-poor star in the galaxy's thick disk, a population of stars that formed when the Milky Way was much younger. Professor Chris Lintott, co-author of the Oxford study and presenter of BBC's The Sky at Night, explains that there's approximately a 2/3 chance this comet is older than our 4.6 billion-year-old solar system. If confirmed, 3I Atlas would represent a pristine sample of materials from the early galaxy, preserved in the deep freeze of interstellar space for eons. The object's ancient origins could explain its unusual characteristics. Unlike comets in our solar system, which have been repeatedly heated during passages near the Sun, 3I Atlas may be experiencing its first encounter with stellar radiation in billions of years. This pristine nature could account for its unexpected brightness and activity patterns. Dr. Michelle Bannister from the University of Canterbury notes that the gases released as 3I Atlas is heated by the Sun will test theoretical models about ancient comet composition. This temporal perspective transforms 3I Atlas from merely an interstellar visitor into a potential time capsule from the galaxy's youth. Trajectory and future encounters. So, 3I/Atlas is currently following a precisely calculated path through our solar system that will bring it to perihelion, its closest approach to the Sun, around October 30th, 2025. At this point it will be approximately 206 million kilometers from the Sun, just inside Mars's orbit, but still at a safe distance that poses no threat to Earth. The object's trajectory offers both opportunities and challenges for observation. During its closest solar approach, 3I/Atlas will be positioned on the opposite side of the Sun from Earth, limiting direct observation during its most active period. Dr. Astor Taylor, a graduate student in astrophysics at the University of Michigan, explains that despite the object's incredible speed, astronomers will have several months to study it. The comet will remain visible to large telescopes until early 2026, after which it will fade into the darkness of space, never to return. On October 3, 2025, 3I/Atlas will make its closest approach to Mars, providing an opportunity to measure how planetary gravity might subtly alter its trajectory. The object's outbound journey will take it beyond Jupiter's orbit by mid-2026, beyond Saturn by 2027, and eventually beyond the influence of our solar system entirely, resuming its eternal voyage through the galaxy. Scientific implications and astrobiology. The discovery and study of 3I Atlas carries, honestly, some pretty profound implications for our understanding of planetary system formation, the distribution of organic materials throughout the galaxy, and potentially the origins of life itself. As the largest confirmed interstellar object, it offers an unprecedented opportunity to analyze material from another stellar system in detail. If spectroscopic analysis reveals complex organic compounds within 3I Atlas, it would support theories that interstellar objects serve as vehicles for distributing the building blocks of life across the galaxy. This concept, known as panspermia, suggests that life's ingredients, or even life itself, might travel between star systems aboard comets and asteroids. The object's ancient age adds another dimension to its astrobiological significance. Materials preserved in 3I Atlas for billions of years could contain information about the early galactic environment when the first generation of planets was forming. Dr. Rosemary Dorsey from the University of Helsinki emphasizes that studying 3I Atlas provides insights into the role that ancient interstellar comets play in seeding star and planet formation across the galaxy. The object's composition and behavior could reveal whether the chemical ingredients necessary for life are common throughout the cosmos. The discovery also informs models of planetary system evolution, suggesting that the ejection of material into interstellar space is a common process that connects distant stellar systems through the exchange of matter and potentially biological information. Future detection and exploration. The discovery of 3I Atlas comes at a pivotal moment in astronomy, as new survey telescopes prepare to, really revolutionize our ability to detect interstellar objects. The Vera C. Rubin Observatory, scheduled to begin operations soon, will photograph the entire visible sky every few nights, creating a comprehensive movie of the cosmos that should dramatically increase the rate of interstellar object discoveries. Predictions suggest that Rubin Observatory might detect between 5 and 50 interstellar objects during its 10-year survey, with some potentially as large as 3I Atlas. The discovery also highlights the potential for rapid response missions to intercept future interstellar objects. While 3I Atlas was detected too late for any spacecraft to reach it, several space agencies are developing concepts for high-speed interceptor missions that could be launched on short notice when the next visitor is discovered. The European Space Agency has proposed the Comet interceptor mission, designed to study a pristine comet or potentially an interstellar object. NASA and other agencies are exploring similar concepts that could provide direct sampling and analysis capabilities, opening entirely new frontiers in space exploration. These future missions could answer fundamental questions about interstellar objects that remote observation cannot address, including their internal structure, precise composition, and the processes that ejected them from their home systems billions of years ago.
A new era of cosmic discovery.
The arrival of 3Y Atlas represents more than just another astronomical discovery. It marks humanity's entry into a new era of cosmic exploration where we can study material from distant star systems within our own solar system. Each interstellar visitor provides a unique window into the processes shaping planetary systems throughout the galaxy. As 3I Atlas continues its journey through our cosmic neighborhood, it carries with it secrets from an ancient star system that may have died billions of years ago. The data collected during its brief visit will be analyzed for years to come, potentially reshaping our understanding of planetary formation, the distribution of life's ingredients, and our place in the galactic community. The rapid succession of interstellar discoveries, from Oumuamua to Borisov to 3Y Atlas, suggests that our solar system exists within a busy galactic highway where objects regularly travel between star systems. This realization transforms our perspective from viewing our solar system as an isolated island to understanding it as part of a vast, interconnected cosmic ecosystem. Future generations of astronomers will have access to increasingly sophisticated tools for detecting and studying these cosmic messengers. Each new discovery will add to our growing understanding of how matter, and potentially life itself, spreads throughout the galaxy. 3I Atlas may be just the beginning of a new chapter in human exploration of the cosmos, one where the universe comes to us in the form of ancient travelers from distant stars. The discovery of 3I Atlas opens an unprecedented window into the ancient cosmos, offering humanity its first detailed look at a massive object from another star system. As this colossal interstellar visitor races through our solar system, it carries secrets from a distant world that may have existed billions of years before Earth formed. The data collected during its brief passage will enhance our understanding of planetary formation, the distribution of life's building blocks, and our cosmic heritage. What other ancient messengers await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible cosmic discoveries. Until next time, keep looking up. A Falcon 9 rocket just spotted something moving on the surface of an object from another star system. That was the claim that recently exploded online, suggesting SpaceX secretly sent a mission to an ancient interstellar comet. But what is the truth behind this cosmic visitor and the viral rumors? The reality is even more fascinating than the fiction, and it forces us to confront a critical question about humanity's future in space. Let's explore this together. What makes 3I Atlas special? So what's the big deal about this specific visitor? Imagine an object older than our own sun, which is about 4.6 billion years old, carrying secrets from a star system we've never seen. That's what we're talking about here. While the name 3I Atlas is fictional, it's clearly inspired by real objects like Comet C 2023 A3 Tsuchinshan Atlas. This comet is a long-period visitor from the Oort cloud, a theorized sphere of icy bodies over 150 trillion kilometers away. True interstellar visitors like the ones discovered by astronomers Robert Warwick and Gennady Borisov come from even farther. Warwick's discovery, Oumuamua, was a 400-meter-long enigma traveling at a blistering 87.3 kilometers per second relative to the Sun. Borisov's comet was moving at a more sedate but still incredible 32 kilometers per second. These objects are time capsules containing the original chemical ingredients from another star's formation. Scientists believe analyzing even a gram of material from one of these could reveal isotopic ratios and molecular structures that don't exist in our solar system. It's like receiving a message in a bottle from across a cosmic ocean. This isn't just another rock, it's a pristine sample of galactic history delivered right to our doorstep. The Falcon 9 connection debunked. Let's get straight to it. Did a Falcon 9 rocket actually intercept anything on a comet? The short answer is no. The viral claim suggested a secret SpaceX mission, but the reality is much more routine. Public launch records show that Falcon 9 rockets are constantly lifting off, with SpaceX having completed over 100 launches in 2023 alone. Their missions are focused on deploying batches of 22 to 23 Starlink satellites into low Earth orbit, typically at an altitude of about 550 kilometers, or launching sensitive payloads for the National Reconnaissance Office. A Falcon 9's job is to provide the initial boost into a specific orbital slot around Earth. It is not a deep space interceptor. The idea of a Falcon 9 spontaneously chasing down an interstellar object moving at over 100,000 kilometers per hour is pure science fiction. The rocket that places satellites in orbit simply doesn't have the fuel, the engines, or the trajectory to perform such a maneuver. It's like using a city bus to try and compete in a Formula 1 race. The bus is great at its job, but it's the wrong tool for that particular track. The viral story was compelling, but it fundamentally misunderstands what these remarkable rockets are built to do. The physics of interception. Why couldn't a Falcon 9 just go and chase a comet? The numbers are staggering, and it all comes down to a concept called delta V, the currency of space travel. To get a payload to low Earth orbit, a Falcon 9 provides about 9.4 kilometers per second of delta V. To catch Oumuamua, studies from the Initiative for Interstellar Studies under a concept called Project Lyra estimated a required delta V of over 30 kilometers per second, maybe even up to 70 kilometers per second depending on the launch window. That's an order of magnitude more energy. Our fastest spacecraft, the Parker Solar Probe, will reach a mind-bending 192 kilometers per second. But only after 7 gravity assists from Venus over 7 years, using the Sun's own immense gravity as a slingshot. It needed a massive Delta IV Heavy rocket just to get started. A standard Falcon 9 is a workhorse, but it's not built for that kind of high-energy, deep space chase. It would be like trying to jump onto a bullet train as it speeds through your station. You can't just run and catch it. You need a vehicle that can match its speed and trajectory perfectly. And that requires an astronomical amount of energy planned far in advance. Alien chemistry possibilities. Here's where things get really fascinating. What if these interstellar visitors are carrying chemical recipes we've never seen before? An object formed in a completely different stellar environment would be built from a different cloud of gas and dust. Telescopic analysis of 2I Borisov, led by scientists like Dennis Bodowitz, revealed it contained anywhere from 9 to 26 times more carbon monoxide than the average solar system comet. This suggests it formed in an extremely cold, carbon-rich region around its home star. This raises a profound question, one often explored by thinkers like Harvard astronomer Avi Loeb. Could these objects carry complex organic molecules with structures fundamentally different from those on Earth? Life here is based on left-handed amino acids. Finding right-handed versions on an interstellar object would be revolutionary. It would be powerful evidence for the theory of panspermia, the idea that the chemical seeds of life are spread throughout the galaxy on objects just like these. If we could analyze a sample, we might find that the building blocks of life are common across the cosmos, but maybe they follow slightly different rules. It would be the ultimate test of whether life as we know it is a cosmic fluke or a universal blueprint. 3 missed opportunities. The frustration for scientists is that we've seen these messengers fly by, but we've been unable to do anything but watch. We are 3 for 3 on missed chances. First, there was one Oumuamua, discovered on October 19, 2017, by Robert Warwick. By the time astronomers realized how strange it was already rocketing out of our solar system, far too fast to be caught. Its bizarre 400-meter-long cigar-like shape and its mysterious acceleration still spark debate. Then, on August 30, 2019, amateur astronomer Gennady Borisov spotted 2I Borisov. This one looked more like a traditional comet, with a visible coma nearly 160,000 kilometers across. but it too was moving too fast for any existing spacecraft to intercept. The window of opportunity to launch a mission was just a few months, far too short to build and prepare a spacecraft from scratch. Each of these objects represented a unique, fleeting opportunity to study matter from another star system up close. Instead, we were left observing from millions of miles away. It's like having priceless ancient artifacts float past your window, just out of reach. Future intercept technology. So, are we doomed to just watch these cosmic treasures fly by forever? Not necessarily. The European Space Agency, or ESA, is already building a solution. It's called the Comet Interceptor mission, planned for launch in 2029 aboard an Ariane 6 rocket. This is a game changer. The spacecraft won't have a specific target when it launches. Instead, it will travel to the Sun-Earth L2 point, a stable gravitational parking spot about 1.5 million kilometers from Earth, and it will wait. It will hibernate there for up to 3 years, acting as a rapid response system. When astronomers, perhaps using the upcoming Vera C. Rubin Observatory, discover a new long-period comet, or ideally, a new interstellar object with a reachable trajectory, Comet Interceptor will be ready to go. Once it gets its target, the main spacecraft will release 2 smaller probes. Together, the 3 vehicles will fly through the comet's coma from different angles, creating a 3-dimensional profile of a pristine object. This 3-for-1 approach will give us unprecedented data on the object's nucleus, its gas, its dust, and the surrounding plasma environment. This mission is our first real shot at studying one of these messengers up close. Scientific implications. Let's talk about the bottom line. What's at stake here? The discoveries from intercepting an interstellar object could be transformative, honestly rewriting textbooks on multiple fronts. We're not just talking about seeing another space rock, we're talking about answering some of the deepest questions in science. First, its chemical composition could provide a direct sample of the materials that form planets in other star systems. We could learn if the building blocks of rocky planets and gas giants are the same across the galaxy. Second, studying its isotopic ratios, the specific blend of neutrons in its atoms, could give us a definitive fingerprint of its origin, proving beyond any doubt it came from another star. And perhaps most importantly, as scientists like Avi Loeb argue, we should be open to all possibilities, including looking for chemical signatures of technology. Confirming unique organic molecules would provide powerful evidence for panspermia, suggesting the ingredients for life are widespread throughout the universe. This is about understanding our own origins, the prevalence of life's ingredients, and our ultimate place in the cosmos. It's a chance to move from speculation to direct evidence. Trajectory analysis and mysteries. So how do we even know these objects are from another star system? Well, the answer actually lies in the mathematics of their journey. Objects in our solar system orbit the sun in closed ellipses, but interstellar visitors travel on a hyperbolic trajectory, a one-way trip really. Their sheer speed is the giveaway. But you know, the path itself can hold deeper secrets. For example, a team led by Marco Micheli of the European Space Agency confirmed that Oumuamua had a slight non-gravitational acceleration. It was a tiny but persistent push of about 1.5 millimeters per second squared. The leading scientific theory is that this was caused by the outgassing of hydrogen ice, creating an invisible jet effect. However, the lack of a visible coma to confirm this keeps the mystery alive and, honestly, fuels speculation. This riddle just highlights how much we have to learn. Analyzing the precise path of future visitors could tell us if they are solid, inert bodies or if they're actively shedding material in ways we can't easily detect from Earth, which really challenges our models of what a comet even is. The official facts. So, let's set the record straight, separating the viral fiction from the scientific facts. The object that fueled recent excitement is likely based on Comet C 2023 A3 Tsuchinshan Atlas. It was first spotted on January 9, 2023, and confirmed on February 22, 2023. ATLAS itself stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot near-Earth objects. This comet is not interstellar, it's a long-period comet from the Oort cloud. Its orbit is incredibly long, taking tens of thousands of years. It made its closest approach to the Sun, its perihelion, on September 27, 2024, at a distance of about 58 million kilometers. Its closest approach to Earth was on October 12, 2024, at a safe distance of about 71 million kilometers. Its nucleus is estimated to be several kilometers in diameter, and to be perfectly clear, no spacecraft from SpaceX or any other agency has intercepted this comet. The Falcon 9 launches are real, but they are completely unrelated. The bigger picture. The Falcon 9 story, while inaccurate, highlights a much deeper truth. Humanity is now at a crossroads. For the first time, we have the technology to not just observe these messengers, but to potentially reach out and touch them. The detection of multiple interstellar visitors in just a few years suggests these encounters are actually pretty common. And with new tools like the Vera C. Rubin Observatory coming online, its director, Zeljko Ivezic, predicts we might soon be spotting dozens of these objects every year. We are no longer just passive observers on the shore of the cosmic ocean. We are building the ships to sail it. The development of missions like ESA's Comet Interceptor is the first step toward a proactive strategy. The real question is no longer can we do it, but will we commit? Some scientists are now pushing for a permanent, ready-to-launch intercept program. It's a question of priorities. The choice we make now will define the next great era of space exploration and could determine if our generation is the one that finally answers the question of what lies beyond our cosmic neighborhood. So, Falcon 9 didn't literally chase a comet, but the conversation it started is critical. We are on the verge of being able to sample another star system. The next visitor is coming, and the one after that. The only question is whether we'll be ready to answer the door when it knocks. What do you think? Should we be building a permanent intercept mission, ready to launch at a moment's notice? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss our next exploration into the mysteries of the cosmos. Thanks for watching Future Facts.